Hello guys, welcome to my channel. You're welcome to Master Builders Online Academy. In this module, I'll be teaching you exactly how to solve Fourier series problems effectively. Yes, Fourier series is one of the advanced topics in mathematics. One of the advanced topics in mathematics. And as a result, a lot of persons are having issues in solving problems on Fourier series effectively. And this is one of the reasons why this video is coming to help you demystify, hold you by the hand, and teach you the principles that you need to know so that you will be able to gain mastery in solving problems on Fourier series. Yes, guys, anybody can solve problems on Fourier series. The only thing that you need to know is the principles that work. Just as usual, I always tell you that when you understand principles, you become a principal. And when you understand boundary conditions, you will not overstep your boundary. So there are boundary conditions that will position you enough to understand what we have here as Fourier series. So many boundary conditions. And one of the things is that these boundary conditions, these principles, helps you to gain a lot of, stability in order to handle problems on Fourier series effectively. So now guys, one of the things you must do for me and do for yourself in this video is that you should not skip any part of this video. Why? Because every part of this video is encrypted with principles that works. And understand that these are the principles that we're actually here to teach you, because you have some of these problems solved in your materials, you have some of these problems solved in your textbook, and you have some of these problems solved online on PDF format. But here we are so that we can show you exactly how it works. So the only way you can maximize and get full advantage of these principles is that you create total attention for this. Yes, there are a lot of distractions around you, but you have to ensure that you create total attention, create maximum attention for yourself. Because when you are able to do that, then you will be able to maximize the principles that I will be teaching you in this module. Guys, I tell you the truth, I lie not. If you watch this video from beginning to the end, your challenges on these topics are over. I tell you the truth. I guarantee you that. Just stay tuned and ensure you do not skip any part of this video. Get your writing material and let's dive into the business. So guys, the very first question that you must answer is, what is Fourier series? What do you understand by the word Fourier series? Because for you to start solving a problem under a particular topic in mathematics, you must first of all know what that thing is all about. So before we will start solving problems on Fourier series, the first examination we examine ourselves is to ask ourselves, what is Fourier series? If you are asked, so now let's define Fourier series in a short while. Fourier series, as defined, is an expansion of a periodic function f of x in terms of an infinite sum of sine and cosine. All right. So Fourier series is an expansion of periodic function f of x in terms of infinite sum of sines and cosines. All right, which is actually trigonometrical function. Right? Yes, we are actually talking about trigonometrical functions. Now, the question, on the other hand, guys, what is a periodic function? A Fourier series is all about what is a periodic function. Now, a periodic function f of x is said to be periodic if its function values repeat at regular interval of the independent variable. All right, so a function f of x is said to be periodic if its function values repeat at regular intervals of the independent variable. So the regular interval between the repetition is the period of the oscillation. One of the things that we must get here is that we should be able to know periodic function. Normally, if you are given that y is equal to 8 sine nx, all right? Because y is the subject of the formula, Y is the dependent variable. It shows that the value of Y depends so only on the value of X, right? So it shows that X here is the independent variable. So what it means now that the value of X at a regular interval over a period. Are you there? So this period accumulated with time is what we call the oscillation. So now in this module, we are not interested much in the definitions, but our interest is basically on the calculation aspect. Having known what Fourier series is and what a periodic function is, guys. So the first aspect that we are going to be looking at now is description of Fourier series. Yeah, the analytical description of Fourier series. How to represent Fourier series and how to interpret graphs on Fourier series. All right, how to convert graphical representations to mathematical equations. So now we have analytical description of periodic functions. So in this particular module now, we shall be looking at analytical description of periodic functions. What this does is that we will be given graphical representation of periodic functions. But our interest there is for us to be able to deduce the equation that was initially used to plot that graph. Are you there? We are to what? Get an equation that will help us get the relationship between the dependent variable and the independent variable, making the dependent variable the subject formula, right? Then, and being able to get the period from which these functions are obtained. Are you there? So in this Fourier series, the one period is represented by V. So this period is attained when you have a complete cycle, an oscillation, one complete cycle. Take for instance, I have a line like this as a graph, then I move this way. Then by the time I move up this point, I have one complete cycle. Or otherwise, I have something like this, then something like this. Then I move this way, I move this way. These I have had a complete cycle. It can be any of the mathematical shape, plane shape that you know, right? It can be any of these shapes. But one of the things that is paramount here is that you should be able to know when one period is achieved. Why? Because the problems we are going to be looking at now, they are called the non-sinusoidal functions. Alright, so these ones, they have nothing to do with cosine, they have nothing to do with sine. Just as one would define Fourier series earlier. It's actually what? A function of sine and cosine, infinite function of sine and cosine. But this aspect, when we'll be looking at the analytical description, we are not interested in looking at the cosine function or the sine function. So we are looking at the non-sinusoidal analysis. So guys, let's dive into this as we begin to solve problems. But before we start solving problems, like I did tell you earlier, there are principles that you need to know. So how are these periodic analyzed? How do you analyze this periodic function? Remember that in mathematics, lines can be represented in three forms. Alright, so lines can be represented in three forms. It's either a line is represented as horizontal, which is A to B. A line is represented as vertical, A to B, or B to A, as the case may be, or a line is represented as inclined, A to B. This is perfectly horizontal, this is perfectly vertical, but this is neither vertical nor horizontal, and as such we call it slanted lines, right? Now look at it. In analyzing periodic functions, you must understand the role these three lines play in any graph that you are given. If you are given a horizontal line or you are dealing with a horizontal line, the way it behaves is different from the way this guy behaves. Alright? But one of the things that you need to also understand here, very, very important, is that while finding the periodic function, which is f of x, and the period, which will be the anchor question that you can be asked under analytical description of periodic function. These are the two questions you can be asked. Now take note of this. You can only consider horizontal lines to get a function of x, or you consider an inclined line to get your function of x. Vertical lines does not count. I repeat, vertical lines does not count. So the question is, why does horizontal line count? Then inclined line counts, and the vertical line do not count. Why does it not count? One of the major reasons why horizontal line counts is that there is a variation in the function of x. Variation in the function of x. Take for instance, this is a graph. Okay, of course you know that this is x-axis, then we have this is y-axis, right? Then let's take for instance, this is our origin, which starts from 0. Okay, now when I move along x this way, if this is origin, then take for instance, this is 2, then here we have 4, then we have 6, just like that, then we have 1, 2, 3. As the case may be, let's assume this is a graph that we have. Now, this analytic f of x can only exist, which is the same thing as y. Don't forget that f of x is y, which is the value here. F of x can only exist when there is what? A variation in the periodic function f of x. Alright? So you must have a variation along x axis. So when I have a horizontal line, maybe from here to here, the value of x changes from 1 to 6, right? In a speed. Now again, if I have an inclined line this way, the value of x also varies from 6 to 6. But if I have a vertical line here, you see that the value of x does not change. It remains as 4 all throughout this part. But when I take part, this horizontal part, the value of x changes from 2 to 6. If I add the inclined line, the value of x also changes from 2 to 6. It can be more than 6, it can be depending on what we have, alright? But for what we have here now, this is it. But when I take a look at vertical line, there is no variation in the value of x, which is the independent variable that was indeed mentioned while we were defining periodic function. Okay, so there must be an interval between the value of x. So if this is my x1, here will be my x2. Now, if this is my x1, here will be my x2. But if here is my x1, my x2 and x1, they have the same value. So for long as the value of x1 and the value of x2 are the same, it shows that there is no function of x there, because there is no change in the value of x. So understand that f of x exists only when there is changes in the value of x. I hope with these annotated diagrams, I have been able to convince and teach you the principles that you need to know while analyzing horizontal, vertical, and inclined line in the analytical description of periodic what? Functions. Now guys, the next is, if I have horizontal lines, how do I find my f of x? Anytime you have horizontal line, okay, the f of x that you have is equal to the value of y at that level. Why? Because the value of y between horizontal line remains the same. So if this is my graph and I have this, okay, like we had before, let me use this as another diagram. Let's say for instance this is 2, and this is 2, this is 4. If I have horizontal line like this, okay, along this path, the value of y is the same all through. So long as the value of y, if this is y1 and somewhere here is y2, it's still the same thing, right? So as long as the value of y1 is equal to the value of y2, when I mention y1, I'm talking about the value of y at the initial position or original position. Y2 becomes the value of y at the what? Final position, right? So this is it. So as long as on the horizontal line, the value of y1 and y2 are equal, then your f of x is equal to y. What I mean is that anytime y1 is equal to y2, therefore f of x is equal to any of this value because any of this value is equal to y. So as long as y1 is equal to y2, both are equal to y, and your f of x is equal to that y. This is it for horizontal lines. This is the principle. Now, when it comes to vertical lines, like I said, this does not count because we only consider f of x when there is change in x. Now, let's talk about a inclined line, slanting line, right? The line can be slant this way, it can be slant this way, right? It can be like this. Then it can also be in this form, anyway. But provided that it's neither horizontal nor vertical. Are you there? So if this is what I have, then maybe this is A, then this is B again. Alright, this is an inclined line, guys. Now look at it. In this case, when the line is inclined, the value of y1 is not equal to y2. So every time the value of y1 is not equal to the value of y2, therefore you make use of the equations of a straight line. I think I have unveiled the principle so far. Now let me take it again. When you have an inclined line, at this point, take for instance the value of y here is 5. Maybe somewhere here the value of y can be 1. Y. Again, if here is the value of x1, here is the value of x2, but here is the value of y2, then maybe here is y1. So you find out that the value of y1 and y2, they are not the same. So anytime you discover that y1 is different from y2, therefore the equation of lines are required here. And what is the equations of a straight line? The equation of a straight line is given as y minus y1 over x minus x1 is equal to y2 minus y1 all over x2 minus x1. This particular equation here is called the equation of a straight line. So what you do is that the value of x1 that you have, put it here, the value of y1 you have, put it here, the value of x2, put it here, the value of x2, put it here, the value of y2, put it here, just like that. You substitute in there, you are able to find y in terms of x without substitute, right? So this is what you do. So you must understand when to use the equation of a straight line and when not to use the equations of a straight line. So the equation of a straight line is used only when you have non-vertical, non-horizontal line, which are called inclined line or slanting line. Why you make use of direct values when you have horizontal line, but when you have vertical lines, nothing happens because there is no change in the value of x. So guys, if you have gotten a value at this level and you have not subscribed to this YouTube channel, do consider subscribing to our channel and ensure you turn on the post notification bell so that anytime we upload mind-blowing content, you will be notified. Don't forget to share this video, like this video if you are gaining massive values from this video. So guys, with what we have discussed so far, let's approach questions with these principles and see how it works perfectly well. Let's dive into that part. Okay, now guys, we have the very first question on the board. Remember, this is problems and solutions as usual. We have the very first question on the board, question number 1. Okay, we are asked to find f of x and period t in the figure below. Now, this is the figure. X-axis with values, y-axis with values. And like they mentioned, to find f of x, it is our solution. Understand that f of x is always equal to y, whether you are dealing with horizontal line or you are dealing with inclined line. So one of the things you must put in place now is to start invoking those principles and those boundary conditions we mentioned earlier, right? Now let's take a look at this. When we look at this now, this is our origin. Please pay attention to this part. This is our origin. And then from the origin to this point I have 4. And then you see another line here. From here to this point I have 6. Then move this way, then you have 10, then you move this way, you have this, right? Now the journey actually begins from here. Can you see it? So now, where the journey begins from, you can label it A. Then the next point, you label it B. The other point here, we label here C. Then the next point, we label here D. The next point, we label here E. Just like that, F, G, just like that. Okay? Now let's stop it first. Now, having labeled this, the next thing you are quickly going to do is to know where your period is completed, where you have one oscillation or one complete cycle. How do I know that I have one complete cycle? When these figures that I have here are not actually in circular form. And secondly, all the values that I have here, they are all plotted at the positive section of one. None of this shape gone beyond the negative side, right? So we just have everything at the upper level of X. So how do I know that I have obtained a complete cycle? Now you get to understand that you know you have a complete cycle when you begin your journey at one point, and then after walking through the path, you find out that you have gotten to a point that looks exactly as where you initially started your journey from. You get that? Okay, you don't get it. Let's look at it. The journey begins from A. At 3, when we move this way to this point, this becomes line 1, AB. Then we move to BC, BC becomes line 2, which is the vertical line. Then when we now have CD, CD becomes line 3. When we now have DE, DE now becomes line 4. But when we now have EF, remember, EF and AB, they are exactly the same. From A and E are the same position. B and F, they are the same position. Again, how do I know? Is it because the shapes are looking exactly? Well, that can be it. But another thing is, between A and B, the interval is 4. But between C and D, the interval is 6. Now, between E and F, the interval is 4. Because if you remove 6 from 10, you will have 6 minus 10. Or 10 minus 6, you will have 4. That means the interval between this and this are the same. So as long as the interval are the same, it means that if we decide to go with EF, we will still obtain what we obtained for line AB. So long as when we begin our journey from A through B to C, C to D, and D to E, from D to F is the same journey we begin from A to B. So a complete cycle is attained at this E, which is the same thing as D, because E and D, they are the same level, right? Because there is no variation in the value of X. That's one of the reasons why I did mention earlier that the value of Y does not really count. It doesn't count at all. So you see that this level, so you can decide to say, okay, it's at D, it's at E, but naturally it's at E. But line DE is 1 because the value of X remains the same. So we have a complete cycle at E. So from the origin to this point, the value is 6. So that means the period to this graph is 6. We have gotten the value. Why do we need to get the period on time or first? The reason why we just need to get the period first is that this will enable us to know where we will stop our analytical description of this graph. Otherwise, if you don't know, you can just begin to solve to this end. Of course, what you are doing is no longer relevant. So having been able to get the period, I know that my analysis will start from A and end in E. Because if I continue from A through G and to the rest part, I will have what I already had from A to E. So there is no need to continue the same thing, right? So this is the first key. So the next key now to assess is the line present. Line present. Line present. I did mention that there are 3 representations of lines. Line can be represented as vertical, horizontal, and inclined. So in this question, let's look at the lines that we have here. AB is horizontal. BC is vertical. CD is horizontal. DE is vertical, right? So in this case now, there is no inclined line. But we did mention earlier that vertical lines are not considered as line here, right? Why? Because the value of X does not change with time. So if this is true, that means the lines we are going to consider in solving this problem is line AB and CD, because these are the 2 horizontal lines. If vertical line does not count, then it's none of my business to play with them. Alright? So I don't need to do anything with CDB or BC. I have no business with DE. The only business I have is AB, horizontal 1, then CD, horizontal 2. We have 2 horizontal lines. So what do we do now? We start taking the lines one after the other. Now let's start. For line AB, are you with me? Now at A, what you need to do is when you come to point A, look at it, you will get the value of x and y there. Now, this is the point A. The point A that we have there lies on the vertical line. And any point that lies on the vertical line shows that the value of x is 0. So here, x is 0, but the value of y at this point is 3. So this is equivalent to x1, y1. We are done with that. Then again, at B, while we are at B, the value of x now is 4. Check here, the point of intersection. So you trace B to the x-axis, trace B to the y-axis, right? So the value of x is 4, but the value of y is 3. This is equivalent to x2, y2. Now the next thing we are quickly going to do now, haven't gotten these parameters for line AB because you deal with this line by line. So we have line AB now. Haven't been able to pick out the values of point A and point B. The next is check if the two values of y are the same. Of course, from what we have here, where y1 is equal to y2 and both are equal to 3. Can you see it? The value of y1 is 3. The value of y2 is 3. Therefore, y is equal to 3. Hence, f of x is equal to y. F of x is equal to 3. It's as simple as this. This does not require the equation of a straight line. 1, because it is not inclined. There is no inclined line here. Secondly, is that there is no variation in the values of y. The first value and the second value are the same. So anytime they are the same, then pick one of the values and take it to be your y. And remember, y is the same thing as f of x. It's as simple as this. So this is what we have. Then, what do we now say? We say that f of x is equal to 3 at what interval? What is the interval? You now pick the values of x. The first value of x is 0, between 0 less than x less than 4. Don't forget. So you use the values of x to take your interval between 0 to 4. So x is greater than 0 or less than 4. That's what it is. Okay? So we are done finding the equation that gave us this line. Then the next is what? For line CD. Like I did mention, you don't consider line BC because it's a vertical line. And as such, the value of x does not vary. You see, while we got to this level, we have 0 to x to 4. But in this case, there should be 4 to x to 4. There is no such a thing that exists here. So this is one of the reasons why we ignore this, and we are going to equally ignore this. So the next horizontal line is CD. That's why we have CD here. So the question is, what is the value at C? What is the value at D? So at C. Now look at it. At this point, don't forget we take x first. The value of x is 4, but the value of y is 0. Why? Anytime a line falls on x-axis, the value of y is 0. The same way, anytime the value falls on y-axis, on the y line, it shows that the value of x is 0. So here, y is 0. And this is equivalent to x1, y1. Then at D, the value of x has changed from 4 to 6. But the value of y is still at this level, horizontal, is still touching this horizontal axis, right? So it shows that this is equally 0. And this is equivalent to x2, y2. Again, before we know whether we are using the equation of a straight line, without even considering the nature of the line, what we have to do is to check if the two values of y are the same. Of course, without that, y1 is equal to y2 because both are 0. Therefore, where y1 is equal to y2. Is that correct? And both are equal to y. Alright? Or both are equal to 0. And therefore, y is equal to 0. Hence, f of x is equal to y. Then f of x is equal to 0. At what interval? You now take the two values of x, x1 from x1, which is 4, less than x less than 6. This is it. So now, if we move from C to D, this is also a vertical line that will be ignored. And because we are going to ignore this line, and if we are to take C, E to F now, we will have exactly 3 that we had for A and B. So we stop our analysis here. So what we just need to do now is to collate these two functions in one. We say, therefore, f of x is equal to f of x is equal to. So the first value of x is 3, f of x, and that is between 0, less than x, less than 4. Then the next value of x is 0, which is between 4, less than x, less than 6. So this is the function of f of x. So therefore the period phi is equal to 6. So you can say f of x is equal to f of x plus 6. This is the required solution to this very question. Simple as this. Guys, is this not simple? Very, very simple. Like I do say, when you understand principles, you become a principal. When you understand boundary conditions, guys, you will not overstep your boundaries. So very quickly, let's look at the next question, which will be question number 2. All right, guys. Now we have question number 2 on the board. All right. Now we are asked to find f of x and period phi in the figure shown below. All right. Now this is the figure. This is y-axis, x-axis, and then these are the lines plotted. Okay. These are the lines, like you see here. These are the lines. Okay. This is what we have. So, like I said earlier, the first thing that you have to do here is to what? Get the period, so that you will know where to stop your analysis. Get the period, so that you cannot be doing the same thing that you have always been doing. You cannot be doing the same thing you have done before. So in order to maximize and be on the safer side, get the period first. Okay? So in order for us to get the period now, all we need to do is to know where the journey begins from. So the journey actually begins from the origin. This is where the journey begins from. Started from here and made to this point. So we can call here A, then we call here B. When we move to this point we can call this point C, right? Then when we move to this point becomes D. We move to this point can become E, just like that. Now the next, after getting this, we have line AB, BC, CD, DE, EF, just like that, right? Now, having been able to label this line, and then this is line 1, line 2, line 3, line 4, line 5. I may not solve for all these lines. I only need to solve for a line that is within one complete cycle. That's all. So, how do I get my one cycle? Now, let's look at it. We begin the journey from here, then we end here for line 1. Then from line 2, we move from this to this point. Right? This line AB is a slanting line. Now, when we move from C to D, it is also a slanting line like this. And as you can see them, they are like parallel lines. Let me not use the word that they are parallel lines. So they are like probability, right? They are like parallel lines. But how do I get to know whether these two lines are exactly the same? The interval between where this guy starts from A to B is 8. Now, the interval between where C and D is also 8, because if I remove 8 from 16, I will also have 8. That means my complete cycle on this graph for non-sinusoidal graph, it will end at C. So the period of this graph now is 8. I'm only interested in line AB, and line BC. And more also, my interest is just on ABY because BC is a vertical line, and vertical line does not count. Why? Because it's a condition, boundary condition, because the value of x at this point BC remains as 8. So long as the value of x does not change from one value to another, there cannot exist a function of x on that part. As simple as this. I think I'm beginning to blow up your mind, right? I'm blowing up your mind. Do well to share this content for the benefit of others within your university cycle and beyond the country. Alright? Now let's go. So if this is a thing at this level, the next thing we are quickly going to do now is to start taking these lines one after the other because we have already known our period. The period is 8. So every of our analysis is going to stop at 8. And the only analysis that we have here now is just on line AB. Because line BC is a vertical line that doesn't count. Okay, so we have for line AB, you move at A. What are the values? At A, both x and y, since this is origin, both x and y are 0. Then this is 0, 0, which is equivalent to what? X1, y1. Then at B, while at B, trace here the value of x. This is B, trace it down, the value is 8. This is B, trace it to the left end, the value is 5. That means this is 8, 5. And this is also equivalent to x2, y2. Having gotten this, the next thing we are quickly going to check is to check if the two values of y are the same. y1 is 0, y2 is 5. Guys, are these values the same? Please answer me. Are they the same? Not at all. So, because they are not the same values, all we just need to do now is to apply the equations of a straight line so we can get the relationship between them. That's as simple as that. So now how do we get this? We say, okay, since y1 is not equal to y2, then apply the equation of a straight line. And what is this equation of a straight line? That equation is given as y minus y1 over x minus x1 is equal to y2 minus y1 over x2 minus x1. Value of y is unknown, x1 is 0, y1 is also 0. And this is equal to 5 minus 0, 8 minus 0. I hope you can get this clearly, right? That's all. So automatically, this is y over x is equal to 5 over 8. Because when you remove 0 from 5, it gives you 5. When you equally remove 0 from 8, it gives you 8. If you remove 0 from y, you have y. Then if you remove 0 from x, you have the same thing as x, right? Now let's push further. Having gotten this, all you need to get here is to get the value of y, or make y the subject of formula. That's all. So when we do this, all we simply need to do now to make this subject of formula is to cross multiply. And when we do that, just allow only this guy to multiply this. Because if we do general cross multiplication by saying x multiplied by 5 and 8 multiplied by y, we will still have to divide both sides. So what we just need to do now to clear off this is to multiply through by x. And if we multiply through by x, we will have y is equal to 5 multiplied by x over 8. This is the answer to this, right? Now we have been able to make y the square formula. So since we know the value of y, then we already know our f of x. Therefore, f of x is equal to what? Y. Hence, f of x is equal to what's y? 5x over 8 at what interval? Come here, the value of x here, x1 is 0, x2 is 8. So it's between 0 less than x less than 8. My people, this is it. Having gotten this now, we will have moved to BC to become our next line. But vertical lines are not important here. And I've given you reasons why this is not important. Then the next line will have got CD. So C to D, the interval is 8. And it will give us the same thing as we have here, 5 over 8. You can try that out. So, but for this question, this is what we have. We definitely have now that period T is equal to 8 units. All right. Then we have f of x is equal to f of x plus 8. And then we have f of x is equal to 5 over 8x from 0 less than x less than 8. This is the answer to this very question, guys. So, like I said earlier, these problems are very, very simple. They have been difficult to you before now because you have never been exposed to the truth. Now I have exposed you to the truth and I've given you the ability to go and solve as many problems as you wish. Remember, in Master Builders, our interest is not to solve hundreds of problems, but our major aim is to teach you one problem and use that idea, that concept to solve as many problems that you encounter. I hope these problems you have solved so far has empowered you. But meanwhile, we want to solve a problem that looks very, very complex. Now next. Okay, guys, welcome back to class again. Now we have question number 3 on the board, and then let's look at the question. Now we are asked to find the f of x and period p in the figure shown below. And this is the figure. In the vertical direction, we have 2 here, and this 2 is maintained along this line or through the path, right? Then along the x direction, we have 2, we have 4, we have 6, we have 8, we have 10, we have 12. Then that is not a problem. Then the next thing is we do is to trace the line. This is the line. This is another line. Please watch me. If I tell you cannot hear me very well, please watch what I'm doing here. Okay? Then from here to this point, and then from here to this point, just like that. So the next thing we are quickly going to do, guys, is to first of all label this and then get our period. So let's take, for instance, this is where the journey began. Let's take here as A. Let's take here as B. You can, guys, you can actually use any of the alphabetical letters that you wish to use. Any, all right? But just prefer that we are using A and B. Okay? You can use P, Q, R, any alphabetical letters at all, or any symbol of your choice. Okay? So from B to this point, you can call this point C. All right? This point here is C. Then this point becomes D. This point here becomes E. Then just like that. Of course, we may not need all of these lines to be able to get our function of x, because the function of x is only required within one complete cycle, as I've earlier stated, right? So if this is understood, then now the question is, where do I achieve or attain one complete cycle? So you get that first, so that you won't solve problems you are not supposed to have solved, okay? And that will take your time. If we begin our journey from A, it starts from origin, right? And then if we move this way to this, we have line AB, then we have line BC, then we have line CD, we have line this. Now from A to B, I have the interval of x to be 0 to 2. And now from B to C, I have the interval to be 4. From here to here is 4. If you remove 2 from 6, you have an interval between this period as 4, right? Then, when you now move from C to D, the interval between C and D is 2. If you remove 6 from 8, you will have from here to here as 2. Now, coming back to AB, you will find out that this line, the way AB inclined, is the same way CD is also inclined, right? The way this is the same way this guy is. So this line is actually parallel to this line, on the ground that the depth here from here to here is 2. And that from here to here is 2. So that means we will obtain our complete cycle at this point, because what we are going to be doing from C to D is the same thing we have already done from A to B. And what we will be doing from D to E is what we have done here from B to C. That means we do not need to stress ourselves going to our next thing where we'll be calculating for CD and DE, because they represent this first triangle. If we call this triangle, right? That's what we have. So ABC is still the same thing as CDE. So we'll go with ABC. So once we are able to calculate for ABC, then we stop our analysis here. Is that taken? Now, if this is taken, then the next thing we are going to do now is to start taking these guys one after the other. So we have ascertained now that the period for this function is 6. Our analysis will stop here. So now let's start the analysis. So we have for line AB at A both x and y are 0 because that is the origin, right? Then this is 0, comma 0, and that's equivalent to x1, comma y1. Then we move at B. When we are at B, this is B, you trace B down, the value of x there is 2, and when we trace this, the value here becomes to 2. We have 2, comma 2. This is equivalent to what? x2, y2. Now the next thing we are really going to do for this line, having gotten the values for the 2 points, the initial point A and the final point B, is to ascertain whether the value of y1 is equal to the value of y2. If it is equal, we have gotten our answer. But if it is not equal, then we will make use of the equation of the straight line. So looking at the value of y1 is 0, x2 is 2. So it shows that y varies. So because of this variation, there is a call to the application of what? The equations of a straight line. So all we just need to do now is that since y1 is not equal to y2, then apply the equation of a straight line. And the equation is given as y minus y1 over x minus x1 is equal to y2 minus y1 over x2 minus x1. That's it. The value of this guy is y minus 0 over x minus 0. Then this is equal to y2 is 2, y1 is 0, 2, x1 is 0. So when we subtract this, we have x over y over x is equal to 2 over 2. Now guys, 2 into 2 will give us 1. So it shows that y over x is equal to 1. And when we make y the subject of the formula, which is the dependent variable, yx is the independent variable, if we cross multiply, we have that y is equal to x times 1. And x times 1 is 1x, which is the same thing as x. Now, therefore, f of x is equal to y. Then, hence, f of x is equal to, what is y? X. Within what range? Come back to where A, which is your starting point. Within 0, use the two values of x. 0 less than x, less than the second value of x is 2. This is for this particular function. It's as simple as this. Haven't gotten this. The next thing is what to find for what line CD. So when we move from line BC, for line BC again, all we simply need to do is to what? Take at B. The value is still 2, 2. Don't forget, the value of B here is the same thing as the value of B here, 2, 2, 2. And this is now equivalent to x1, y1. Now at C, while at C, the value of x has changed to 6. But the value of y here, because this point is in line with S as the value of y here is 0. This is equivalent to x2, y2. Now, comparing these 2 points, the value of y1 is different from the value of y2. So, because of this difference, we will equally make use of what the equations of a straight line. So now, I already have the equations of a straight line here, so I don't need to what? State the equation, so that this place will be enough for us to get our general solution. Okay? So all I need to do now is apply the equation of a straight line to line BC. I will have y minus y is 2 all over x minus x2, y1, all of it. Okay, so this is y1, x1. Then is equal to y2 is 0 minus 2 and this is 6 minus 2. So we have been able to substitute in the values of x1, x2, y1, y2. All we need to do now is to find a way to make y the subject of formula in terms of x. And then we have y minus 2 over x minus 2 is equivalent to minus 2 over 4. And this is equivalent to minus 1 over 2. 4 into itself is 1. 2 into itself is 1, and 2 into 4 is 2. So by the time we cross multiply, this guy will multiply this negative 1, and 2 will multiply this. So automatically this is 2 multiplied by y minus 2 is equal to minus 1 multiplied x minus 2. Denominator multiplies this numerator, this denominator multiplies this. Cross multiplication, right? Then 2 multiplied by y will give us 2y, and 2 multiplied by 2 will give us 4. Then minus 1 multiplied by x will give us negative x, and negative 1 multiplied by negative 2 we have positive 2. Now remember, we want to make y the square formula, so we take this negative 4 to the right hand side. And then we have 2y is equal to, when negative 4 crosses, it becomes positive. So plus 2 plus 4. And then y, 2y will have given us 6 minus x, right? 2 plus 4 will give us 6. So I decided to arrange or rearrange this, taking the negative as the second term. Is that okay? Now, what we need to do now is that we cannot stop here because we are not looking for 2y, neither are we looking for 3y, but we are just looking for y. So we need to divide both sides by the coefficient of x, by the coefficient of y, right? So we have y is equal to 6 over 2 minus x over 2. Y is equal to 3 minus x over 2. This is the value of y. Therefore, our f of x is always equal to y. Hence, f of x is equal to 3 minus x over 2. Within what range? Again, what are the two values of x? X ranges from 2 to 6. So we have 2 less than 0, less than 2 less than x, less than 6. So this is the what? Equation for line BC. Why this is the equation for line AB. Now, if we decide to go ahead and find equation for line CD, we will have the value we have here. And if we also go ahead to find the equation for DE, we will have the value we have here. So we have completed this cycle. All we just need to do now is to collect these two functions and we are good to go. So now our final answer is f of x is equal to. So the first function is x, right? Within what range? Within 0 less than x less than 2. That's for this. Then the second function, we put it here, which is 3 minus x over 2. Within what range? Within 2 less than 0, less than x, less than 6. That's all. What then is our period? Period. T is giving us what? 6 units. Then you can have that f of x is equal to f of x plus 6. So guys, this is the answer to this very question. It's as simple as this. Very, very simple. So guys, if you are still watching this content to this very level, it shows that this video is giving you lots of values and is truly impacting your life. So in order to appreciate us for this great sacrifice, giving you free videos to watch on YouTube, kindly subscribe to our YouTube channel. If you have not done so, this is the only way you can appreciate us and get us do more videos like this to help you grow your mental capacity. So guys, subscribe to this YouTube channel if you have not done so, and do ensure you share this video, like this video, and make your necessary comment at this comment section. We will solve one more problem before we call off this class for today. Now let's. Wow, guys, welcome to another section. In this session, we shall be looking at question number 4, like we have it on the board. Okay, still applying the same principles. Now we are asked to find the function of x and period 3 in the figure shown below. Now we have the figure as this. So let's quickly analyze this figure or this diagram so we know what to do and where we belong, alright? Now look at it. Please attention now. This is our y line, vertical line, and then this is x axis, right? And then now this becomes the line that we have here for the function. Okay, and then we are asked to find f of x and period here, right? And I did mention that you can keep finding the function of x for these different lines as you are able to connect the intersection between 2 points. Now, take for instance, this is where the journey begins from. If you look at this now, it begins from here. So let's assume we call here A, then we call here B, then we call here C, then we call here D, we call here E, then just like that. We may calculate for AB, calculate for BC, calculate for CD. Is that possible? Okay. Then calculate for DE, calculate for E, whatever, just like that. But we don't need to go through all of this stress, we don't have to go through all this. So how do we solve this problem? All we need to do is to know where a complete cycle is achieved, starting from the very initial point. So if I begin my journey from A to B, I have one line. This is where the journey begins from, at a level 2 above x axis. Then I move to this level. From B to C is another line, horizontal. This is a line. Then from C to D is vertical line. And of course, based on this particular topic, CD doesn't count. CD is a vertical line. And you know what happens in vertical line? There is no variation in the value of x. As long as there is no variation in the value of x, then that line doesn't matter. Okay? Then we now move from D to E. Now looking at this, AB is parallel to DE. Can you see this? Parallel lines. It's parallel to DE. Parallel to DE. And also, D begins from, this line begins from level 2, where the value of y is equal to 2. So that's where D will begin from if I am to consider DE. So as long as DE is parallel to AB, this is an indication that these two lines are the same. If I had the opportunity to have drawn this up again, you will see that CE, or whatever letter that would have been on this vertical direction, would have been equal to this. So that means in this question, when we obtain our period at C, at this level, this is when we obtain our period at C. So if we are to obtain our period at C, what is then is the value? Because there is no specific value here. So when I come to the origin, this is origin. If here is given as 2 and here is marked, that means this point here is 1, 2, 3, 4, 5, 6. You get it? So that means the period for this graph is 5. T is equal to 5. Know that. Clear? Then we already know that we are going to stop our analysis here. What do? We start taking these lines one after the other. So we move and begin with line AB for line AB. Now we have at A. The value of at A is that if I trace here down, the value of x is 0, and at this level, the value of y is 2. So I have 0, 2, and this is equivalent to x1, y1. Having gotten that, I move to point B. So at point B, if I trace the value of x here, the value of x is 3. But if I trace the value of y to the y direction, I will have -1. So that means at B, x is 3, but y is -1. And this is equivalent to x2 minus y2. Having gotten this, the next thing we are quickly going to do as usual is to compare the two values of y to see if they are the same. Check if y1 is equal to y2. So when we check now, y1 is equal to 2 and y2 is equal to -1. So the values are totally different. So because of this difference, there is a call to the application of the equation of a straight line. That's all. So with this, we did mention that since y1 is not equal to y2, then apply the equation of a straight line. And then what is the equation of a straight line? We have that y minus y1 over x minus x1 is equal to y2 minus y1 all over x2 minus x1. So the value of y, by substitution, we have y minus 2 all over x minus 0 is equal to minus 1 minus 2 all over 3 minus 0. So this is what we have. If we solve this further, it will give us y minus 2 over x is equal to minus 3 over 3. And minus 3 divided by 3, guys, is minus 1. So if we cross multiply x, we multiply -1, we have y minus 2 is equal to minus x. By the time we make y the solid of polar by taking -2 from the left hand side to the right hand side, we have y is equal to 2 minus x. This is it. So therefore, f of x is equal to y, and then hence f of x is equal to 2 minus x. At what range? The value of x is between 0 and 3. So we have 0 less than x less than 3. So this is the answer for the first line. Then we will move to the next line, which is line BC. Now, while we are at line BC, for line BC, at B, what values do we have? We maintain the original value there. We don't need to stress this. But in the same way, if you are at this point, if you trace this to x-axis, you find that here is 3, and if you trace this to y-axis, you find that here is -1, right? So there's no changes there. So now this -1 is equivalent to x1, then y1. Okay? Then at C, if we trace this to C and trace this up at this level, if here is 4, here is 6, the middle is 5, right? So here we have 5 here. Then we put that 5. And at this point, if we trace this again to the direction of y-axis, we equally have this as -1. And this is also equivalent to x2, y2. So guys, what is the next option? The next option is that we need to compare the two values of y. If they are the same, we are good to go. But if they are different, then we need to apply the equation of a straight line. So now the value of y in the first point B is -1. And the value of y2 at C is also -1, right? So as long as these two values are the same, then y is equal to one of the values. F of x is equal to y. Then we are done. I think I deserve a hand of applause because after this class, one of you will take me out there to give me a chill bottle of Heineken, right? Now we have, since y1 is equal to y2 and both are equal to -1, therefore y is equal to -1. And then once you obtain the value of y, you have equally obtained your f of x, because f of x is exactly the same thing as y, right? So therefore, hence f of x is equal to y, f of x is equal to -1. Guys, and f of x is equal to minus 1. Within what range is this value of f of x obtained? Or is this equation gotten? Between x3 and 5. Like I said, don't need to kill yourself. Just come here. If x1 is between x1 and x2. That's all. So you take x1 first. 3 less than x less than 5. This is what we have. Finally, because we have completed a cycle at C, because what we have from C, D to E is what we already have here. Okay? So, we have that in summary, f of x is equal to the first function of x is 2 minus x. At what range? Between 0 less than x less than 3. Then the second function of x is negative 1. So we have minus 1. Within what range? Between 3 less than x less than 5. Then what is the period? Period t is equivalent to what? 5 units. Or f of x is equal to f of x plus t, and our t is 5. This is the answer to this beautiful question that we have here. So the question is, who told you that Fourier series is difficult? Who? Who told you? Who have bewitched you? It is never difficult, but it will be difficult if you are not exposed to the truth. For ye shall know the truth, and the truth shall make you free. You are free now, you are liberated now on this topic because the truths, the details, the principles, and the boundary conditions have been handed over to you as a key from the wise masters. So guys, don't forget, if this video has kept you engaged to this level, do consider subscribing to our channel if you have not done so, and ensure you turn on the post notification bell for more exciting videos. So guys, let's solve the very last question on this analytical description of periodic function. With this, I wish you all the best to go and solve as many Fourier series problems under this analytical description of periodic function. We love you. See you in the next. Okay, guys, now we have the next question on the board, which happens to be question number 5. This is it. Question number 5. We are asked to find the function f of x and the period t of the figure shown below. So the first thing we will do here, is to ensure that we are able to describe this graph, analytical description. So let's describe this graph. Now remember, this y-axis, and this is x-axis. In y-axis, I have positive 3, and then at the negative side, I have negative 3, equal interval, all right, amplitude. All right, now if this is done, then we have the first line begins from O, which is the origin, and moves towards this point. So let's take, for instance, we call here A, then we call here B. We move from here to this point, we call here C, from here to here, call here D, from here to here, E, F, G, and just like that, okay, and so on. Haven't gotten to label all of these points of intersections. All then we need to do is to what? Check where our period stops, so that once we are able to get the period, we'll know how many times we will calculate for f of x and where to stop in the calculation of f of x. Now, to have this done, check. We begin our journey from A, right? From A to B is a line 1. From B to C is the line 1. Now remember that this A started from the origin. That's where the journey begins from. So we are going to stop at another station that begins from this level where y is equal to 0. So we move to this level, we have y to the negative 3, we move to this level, y remains the same. But at E, what we have at A is exactly what we have here at E. It's exactly what we have here at E. So that means the journey we begin from A to D is what we also begin from E towards the infinite end, right? So our period will stop at 13D. Because what we have at E is a continuation of A. So therefore, line AB is the same thing as line EF. And line BC is the same thing as line FG. And line CD is the same thing as the one that continues here to whatever level it gets to. Are we there? So we stop our analysis here. Now within this ring now, how many lines do we have? AB, BC, CD. 3 lines. Okay, now that we have 3 lines, how do we get this problem solved? We begin to take these lines one after the other. Okay, so we begin from line AB. This is already our solution, as we all know. For line AB at A, which is the origin, both x and y are equal to 0. And this is equivalent to x1, y1. Then at B, if I am here, if I trace the value down, I have that x is 4. Don't forget you take s first, and when I trace this way, I have that this is what? 3. And this is equivalent to x2, y2. Having been able to get the values at each of these points that make up this line, the next thing we are simply going to do is to what? Check if the values of y at the first point and at the second point, or at the original point and at the final point, if they are the same or if there is variation in the values. So if there is variation, then there is a call for the use of equation of a straight line. Now let's check. This is y1, which is 0. This is y2, which is 3. That means the values vary. So we have since y1 is not equal to y2, then apply the equations of a straight line. Now, what is the equation of a straight line? Y minus y1 over x minus x1 is equal to y2 minus y1 over x2 minus x1. Of course, we already know the values of x1, x2, y1, and y2. Okay, so we don't substitute in our values. We have y minus 0 all over x minus 0. At the initial level, both were 0. Then at the final level, this is 3 minus 0, and then 4 minus 0. So automatically, this will give us y over x. If we remove 0 from y and then remove 0 from x, we have the same result. And similarly, at the right hand side, 3 minus 0 will give us 0, and 4 minus 0 is equally 4. Okay? All we need to do now is to find a way to make y the same formula. Then, if we multiply through by x, we'll be able to make y the same formula, right? Just all cross multiply. And if we have that, then automatically y is equal to 3 multiplied over 4 multiplied by x. This is it. Since we obtained the value of y, we have only obtained the value of f of x. So for this line, f of x is equal to y, right? And then, therefore, f of x is equal to 3 over 4x. At what interval? Come to your point A, 0, between 0 and 4. Use the two values of x, x1 and x2. So x1 is less than x2, and then x2 is 4. So we have been able to obtain the equation for line A. We then move to line BC until we have a complete cycle. So for line BC, at B, don't need to stress yourself, use the same value you had before, 4,3. And this is equivalent to x1, y1. And then at C, while at C, guys, look at it here. While at C, you will trace this point to the horizontal direction. You find out that the value of x there is 10. And then if you change this to the vertical direction, we find out that the value of y there is negative 3. Negative 3. So we have negative 3. And this is equivalent to x2, comma y2. Having been able to get the values for each of these points, the next we are going to do to know what will become our fields is to check if the two values of y are the same. So if they are the same, then there will not be need for us to apply the equations of the straight line. But on the other hand, if they are not the same, then there is a call to the application of the equation of a straight line. Now let's check. So at point B, y1 is equal to 3, and at point C, y2 is equal to negative 3. Plus 3 and minus 3 are two different values entirely. Don't forget this. Two different values entirely. It shows that y1 is not equal to y2 as long as both are not positive positive or both are not negative negative. Since you have one as positive and the other as negative, they are never the same. So we then have, since y1 is not equal to y2, then apply the equations of a straight line. Now the equation of a straight line has already been stated here, so I don't need to restate it again. All we just need to do now is to put in the value so that we go to maximize this page that we have here. So what is our y1? So at this level now, y1 is minus 3 all over x minus 4. Everything taken at d. Then y2 is negative 3 minus negative 3 minus 3. This negative 3 here minus y1 all over x2 is 10 and x1 is 4. So this will give us this over x minus 4, and this is equivalent to minus 6 over 6. If we remove 4 from 10, the end product is 6. Now remember, 6 divided by 6 will give us this as negative 1. So what do we do now? Remember, the interest here is to actually make y the subject of formula. And to have this achieved, we need to first of all now divide or cross multiply, right? So if we cross multiply, we will have this as y minus 3 is equal to negative 1 multiply x minus 4. And then if we open the bracket with this negative 1, our end product will give us minus x plus 4. Remember, negative 1 multiplied by negative 4 will give us positive 4. I do always make use of this great sentence that for the product of two factors to be positive, the two factors will either be positive positive or both are negative negative. Principle. And again, if the product of two factors is to give you a negative value, one of the factors won't be negative. One must be negative, not both. One must be negative. So when we multiply this is positive, this is negative, we have negative. But when we multiply this, because both were initially negative, their end products will give us a positive value. I am not supposed to be doing all of this because at this level, this is advanced maths, very, very advanced level mathematics, right? So in making y the standard formula being our choice, we have that y is equal to minus x plus 4. Remember, as we take negative 3 from the left hand side to the right hand side, it automatically becomes plus 3. Then we have y is equal to minus x plus 3 plus 4 will give us 7. Alright, 3 plus 4 is 7. Now to rearrange this in order to have the positive come first before the negative sign, then we have y is equal to 7 minus x. This is therefore f of x is equal to y. On what ground? Our f of x, hence f of x is equal to 7 minus x. Between what range of x? Between x1 and x2. So between 4 and 10, we have 4 less than x less than 10. This is the equation for this particular line BC. Then we progress toward line C. We have 4 line C. At C, don't forget, you already have a value there before. At C, that will not change. So we have 10, negative 3. And this is equivalent to x1, then y1, right? Then at D, while at D, guys, pay attention to this. While at this, if I trace this D to the horizontal direction, to x-axis, the value there is 13. But if I trace it to the y direction, the value there is negative 3. So this is 13, then negative 3. And this is equivalent to x2, y2. Now guys, looking at this question as we have on the board, or where we are now at this current point, what we have to do is to check if the two values of y are the same. If they are the same, there is no need for the use of the equation of a straight line. But if not, we just dive into the application of the equation of a straight line. You see that these principles actually are what you need to gain mastery. Okay, now let's dive in. When we check at point C, the value of y is negative 3, which serves as y1, point 1. Then we'll come to the second point. The value of y there is negative 3 also, which is y2. So looking at these 2 points, the value of x1 and x2, they are the same. So long as they are the same, therefore our y is equal to 1 the value. So we have 6. y1 is equal to y2, and both are equal to negative 3. Can you see this? Then f of x is equal to y, and then f of x is equal to what? Minus 3. In what range? You now use the values of x. So the first value of x, x1 is 10, and the second value of x is 13. So it's between 10 to 13. Then we have 10 less than x less than 13. We are done with this. Then the next is to move from D to E. Now from E to F is the same as A to B. So if we decide to go ahead and calculate for this line, we are still going to have 4 over 3x between 13 and 17. If you doubt this, check it out by showing it. Okay, so this point here with the 13, 0, while the second point here will be 17, 3. So the two values of y, they are different. Then you will make use of the equation of the straight line. When you solve with these 2 points, remember this point is point E and this point is point F. When you solve with this, your f of x here will equally be 3 over 4x. Simple as this, guys. So I think I deserve a hand of applause, right? I think I deserve. Okay, now guys, having gotten this, all we just need to do now is to bring together the functions of x. So we have f of x, therefore f of x is equal to the first value we have for f of x is 3 over 4. So we have 3 over 4x in what range? 0 less than x less than 4. Then the second value we have for this is 7 minus x. So we have 7 minus x. In what range? Between 4 to 10. We have 0 less than x. So we have 4 less than x less than 10. Then the final value that we have is negative 3. And if this is our negative 3, what range? Between 0 less than x less than, between 10 less than x less than what? 13. This is what we have. Therefore, period t is equal to 13 units. You can then have that f of x is equal to f into x plus 13. This is the answer to this very question. So guys, you see that solving problems in Fourier series actually require you getting to know principles. And these are one of the things I've helped you to achieve in this video. That after now, you have no problems to worry about when it comes to the analytical description of Fourier series. I've held you by the hand as promised and show you exactly how to solve problems on Fourier series under the subtopic analytical description of periodic function without hiding any simple truths from you. So guys, what I need you to do for me now is to quickly subscribe to my channel if you have not done so. This is the only way you can motivate us to do more and solve more problems and teach you more principles. So guys, don't forget to like this video, share this video, and make your necessary comment at the comment section. Now let me give you a brief. In our next module, I'll be showing you exactly how to solve the main Fourier series questions. I will teach you the concept as well, and then we will dive into solving problems. All of these things require principles. So when you understand all of these principles, guys, you gain mastery automatically. So guys, I will see you in the next module. Don't forget to subscribe. Please subscribe. We love you. Thank you for watching. See you guys in the very next class.